Continuing with the review questions for 4A, number 38. This is from page 334, and 38 says, an airplane flying 600 miles per hour has a bearing of 52 degrees. After flying 1.5 hours, how far north and how far east has the plane traveled from its point of departure? So here comes this. I'm going to go ahead and draw myself some bearings here. And it's going north and east, so it's going this direction right here. Okay. It says it has a bearing of 52 degrees. Okay. So remember, that's from the north to the east. So the bearing is north, 52 east. So right here is 52 degrees. Okay. So using its complement, this is 38 degrees. Okay. So when I want to figure out how far north and east, so I'll label this the east and this the north. Okay, we'll use we got to figure those sides out. Okay, so I need to find at least one side. In this case, I'm going to try to figure out the hypotenuse or the radius, and we know he's going 600 miles an hour. Okay, 600 miles per hour. So that means, and he goes for an hour and a half, 1.5 hours. So in 1 hour he'll go 600, and then the half he'll go 300. So this is 900 miles right there. Okay, so just to kind of clean it up, I have a triangle here of 38 degrees. I have one side, which is the hypotenuse of 900, and I got to find these other two sides. Okay, so I can do it a couple of different ways. I'll go ahead and use sine and cosine. So I'll go ahead and say the sine of 38 degrees equals n over 900, and I'll go ahead and say the cosine of 38 degrees equals e over 900. Okay, I'll let you go ahead and solve those, and if you do, the sine comes out to equaling about 554.1 miles north, and the cosine one that gives us the east value is about 709.2 miles east. Okay. We got the next one here, number 44. Okay, look at number 44 here. This one's a little trickier, and it says a passenger plane is flying at an altitude of 10,000 feet or 10,000 kilometers. See the two towns due east of the plane. The angle of depression to the town are 28 degrees and 55 degrees. How far apart are the towns? So if here's my plane right there. Okay, I have a town here. Call it town 1. And I have another one over here. They tell me they're east, so it's this direction. And I'll call this town 2. And they have a diagram in the book. And basically what it is they draw, if I go straight down, okay, so that's my 90 degrees right there. If I go straight down, that's 10 kilometers or kilometers. Oops, I went too far. Okay. All right. So then the angle of depression, okay, so remember that's from the horizontal to this town here. Okay, and this town, they give me these two. All right. So this one right here is 28 degrees. Okay. And from here all the way to there, okay, is 55 degrees. Just kind of be careful. The diagram can kind of throw you off. So from this horizontal, all of this is 55, and just from here up is 28. And we want to know the distance between these two. Okay, That's our unknown right there. That's what we got to figure out. Okay. Well, that's this triangle right here I just created is not a 90-degree triangle. So what I'm going to do is I'm going to figure out the distance from here to here, right? And the distance from here to here, and I'll just subtract to find that. Okay, so realizing what I've got here. Okay, so from here to here is 55. So this right here is 38 degrees. Sorry, 35 degrees. Okay, and it's hard to tell also, but from this line here and this on the ground, those are, and this being my transversal, these are alternate interiors, so this is also 55 degrees. Okay, or I could just figure that was 35, and then the internal sum being 180. So I'm going to kind of redraw the triangles that I have. So I've got this one right here. Okay. Which is, this is 10, 55 degrees, 35 degrees, and then I've got this bigger one over here. I got to piece some more stuff together for this one. Okay, so this is the hypotenuse right here. All right, so I don't know that, but this is 10, and this is 90. Okay, so I need one of those other angles. Okay, and so for this particular one, you can see that the angle that I'm going to use is going to be a combination of the other two. So looking at it right here, I'm going to say, okay, it's basically this piece plus the 35. Okay, so this is 55, this piece is 28. So I got to subtract the 55, or 28 from 55. Okay, that makes this piece right here 27. Okay, 27. So the whole angle from here all the way to that line gives me an angle of 62 degrees. Okay, and this gives me 28 degrees. Okay, so basically I got to find this. So this triangle here corresponds to that distance all the way to there. That's what this piece is, and this piece here is just there to there. So I got to find these two distances. Okay, I got to find those two distances. So I'll go ahead and work that out. So I'm going to go ahead and set it up. And I'm going to say, and I can do this. I can use the tangents, cotangents. I have quite a few options here. I'm going to say the. Let me see which one I want to do. The cotangent would be this one over that one. So I'm going to go ahead and say the cotangent of 55 degrees is equal to x over 10. Okay, and if I solve that, okay, that's going to come out to about 7 kilometers. Okay, and then over here, if I'll do the cotangent here. Okay, and it doesn't matter which one you did, it'll all work out. But if I did the cotangent here, cotangent of 28 degrees, that would equal, not cosine, sorry. That comes out to about 18. Let me write the whole thing out here, sorry. That comes out to about 18.8 kilometers. Okay. Then I'd have to subtract those, so it'd be 18.8 minus 7 equals 11.8 kilometers. Okay. Would be the distance between the two towns.